Hello, everyone. Like Bowen said, my name is Nihar Bihani. I'm a Senior Product Manager here at Amazon Web Services, and I work in the Amazon Cloudfront team. And first of all, thank you all for joining today's webinar. Really excited to have you here. I think we have some informative content for you here as well as a demo, so hopefully you'll learn quite a bit about both Amazon Cloudfront as well as JW Player by the end of this session. I'll walk you through the agenda quickly. We'll make this fairly interactive, so I'll have Jaron come in and present a couple of slides, then I'll come back and present a few slides. But we want to give you an overview of how Cloudfront and JW Player work independently, and then of course how well they work together. We also want to talk about the media streaming stack and how a player is a crucial component of your streaming stack. And you'll see different ways in which players add value to your viewers' streaming experience. We'll also cover some of the challenges faced by you as publishers when you want to get the perfect streaming experience for your viewers across the variety of different devices that viewers use today. Then Jaron will do a demo of streaming HLS or HTTP live streaming generated by ETS, the Elastic Transcoding Service that AWS has, through Cloudfront, and then play that back using the JW Player. And we'll also want to make sure that we have enough time towards the end to answer any questions that you have, so we'll leave plenty of time for that. So let's just start with an overview of Cloudfront and JW Player first. So from an Amazon Cloudfront perspective, in case some of you are not familiar, Amazon Cloudfront is a web service that's a part of AWS, Amazon Web Services, and Cloudfront is a web service for content delivery. Cloudfront is optimized for low latency and high data transfer speeds for delivering your content to your viewers. There are a variety of different types of content that customers deliver via Cloudfront today, both static content, dynamic content, as well as video streaming, video and audio, both on demand and live. Cloudfront has a global network of edge locations, so we have 43 edge locations currently, and the number of edge locations continue to grow to lower the latency for our customers and their viewers. From a streaming-specific capabilities perspective, Amazon Cloudfront does support all the HTTP-based streaming protocols such as HLS, HDS, smooth streaming, MPEG-Dash, and so on. Cloudfront also has several video streaming specific cache optimizations. So features like the ability to handle range requests or fetching the file from the origin in the most effective way. Cloudfront also focuses a lot on metrics and throughput and optimizing the throughput for delivering your video content to your viewers across the various internet backbones and the ISP networks around the world. In terms of scale, Cloudfront can scale really well to handle your content and the delivery of your content across the globe. So if you have an event that becomes really popular, or content or video that becomes popular over time, or there's a flash crowd, Cloudfront is able to scale that without you needing to worry about scaling your origin infrastructure. Cloudfront also has support for HLS streaming, and you'll be learning a lot more about that today, and in particular how delivering that HLS stream works well with the JW Player. One other thing I wanted to highlight, Cloudfront does have a lot of solutions that work really well with some of the streaming media independent software vendors. So there's an AWS marketplace, and if you're not familiar with the marketplace, it's a way to easily find and use software and services that are available on AWS. Yesterday, for instance, we have a webinar with the Wowza media streaming server, which is a part of the AWS marketplace that you can use to deliver live streams. So I'd encourage you to go to the AWS marketplace and look at what solutions that are available in the media streaming space. So with that, I will turn it over to Jaron to talk a little bit about and give you an overview of the JW Player.
Yeah, thank you. So JW Player is a player that it plays secure video everywhere. HLS, but also progressive videos or AAC audio files. We kind of take away all the abstractions of this runs on this browser and this but not on that browser, and all the small issues and bugs that you have around video playback, especially in HTML5, because that's still quite new. And then in addition to that, for larger publishers, think about media, we offer advertising support, so the standards, the VAST and VPage standards that are widely used in that space. And for our designers and developer community, we have a lot of customization around the video player. So whereas the UI of like an iPad or a default video tag of Chrome cannot be styled, we have a lot of functionality around skinning, having a JavaScript API around the functionality of the playback to have the player talk to your page. There is HD support, closed captioning support, a lot of features for the designers, developers to really create professional embeds. JW Player started around 2005. First year, we were the initial player of YouTube, sold an awesome $15 license for that use of the player. And but as YouTube grew and online video grew, JW Player has grown as well. And right now, our latest version that launched in November is live on approximately 250,000 websites, playing approximately 2 billion videos every month. So there's a lot of usage. We're definitely the most widely used video player in this space.
Okay, thanks, Jeroen. Let's talk a little bit about media players in a streaming stack and the importance of media players. So if you think about it, the video player is really the very first experience that your viewers have when they go to the player and open up a player to start streaming content. So I cannot underscore the importance of having a good player and a good player experience for your viewers. It's something that every single one of your viewers will use when they are playing the content that you're producing and delivering to them. So having the right players and with the right devices can really make that experience great for your users. But at the same time, having a poor player can negate that experience and all of the effort that you may put in making your video content great. And from a delivery perspective, the player can really make or break that experience. If you think about the video players, there's a couple of different options that you have. The first option is, of course, the players that come built into the device that your viewers are on, the devices that they're using. And we'll talk about some of the challenges that presents. And then the second option is, of course, to use a third-party player like the JW player and deliver your video content through that player. In addition to playback itself, there are various other things that you need to think about as you're thinking about the two choices of players that I presented. There are things like branding, analytics, security, monetization. All of these are important components of both the way you want to deliver your video content to viewers as well as the viewers' experience in consuming that content. So, from a branding perspective, it's really, a lot of the customers, a lot of video publishers that I speak with, they're very interested in branding the player to their own website or web application and have a uniform experience for their viewers, with the player branded sort of as a white label branding for their own, layout and design. It's really an opportunity, if you think about it, to create that positive association with your brand and reinforce that brand of yours. There's also an opportunity to have a consistent experience across devices. when it comes to the layout of the player and your viewers, when they learn to navigate across the different features available with the player. They shouldn't have to relearn that when they switch devices and go from an iPad to a smartphone or to their television. And with additional functionality in the players, that often becomes a factor as well in terms of what the players can actually deliver, versus what the native players can deliver when the native players within the devices are available. Because that's an important element of your brand as well. You want to be able to deliver to every single device that's out there, and not just the specific device and what functionality is supported by the native player on that device. Then there's also the analytics, and this is really important as well when you want to understand learn more about your viewers, learn more about your content, the popularity of your content, who's viewing, from where, what's their experience, and how can you improve that experience. You need to monitor things like buffering or errors on the player or server-side errors, so that you can meet your external and internal SLAs that you might have for the quality of service that you want to provide to your viewers. You also need to correlate this to revenue, true drop-off rate, and potentially other ways that your viewer experience can directly impact your business. When you're monitoring, you also need to identify shifts and trends. You want to be able to see which devices or operating systems you need to re-encode your videos for, or which content delivery networks provide the best performance in which regions of the world, and so forth. And a player can really help with collecting a lot of these measurements directly from the player itself, because of the real user monitoring. The player can report back a lot of the metrics about their experience, about the viewer's experience, and where they may have seen the quality of their viewing experience drop off. Security is another important consideration. From a security perspective, there are a variety of different options that are available for you to secure your content when you deliver it to your viewers. So customers will sometimes pre-DRM the content when they're encoding the content. With that option, you're able to DRM your content without the need for a packaging server in the delivery chain, but DRM needs to be supported in your encoder. And also, in addition to transcoding and packaging for delivery, you also need to encrypt the chunks before storing the encoded files back into the storage location. And finally, and important to our context today, your player needs to know how to get a decryption key from the license server and be able to decrypt those chunks. So that's an important consideration when you're thinking about pre-DRMing your content. For long tail content, some customers I've heard from, they will often go with the option of on-the-fly DRM. This is preferred because it allows them to pay the DRM license fees only when the content is requested. But even still, the player plays an important role here in terms of being able to acquire that decryption key from the license server and be able to decrypt the content. A second option that, or really a third option that customers often use is also securing the content using the private content features that might be available with your content delivery network. So there are these CDN-specific private content features. For instance, Amazon Cloudfront, AWS's CDN service, does have a private content feature where you can sign URLs and only allow the viewers who have a valid signed URL to have access to your content. And these security options really, the takeaway from this slide is these security options typically require your player to be able to support the DRM or the CDN private content features that you are using based on your use case to secure your content that you only want your viewers who are authenticated to have access to. And finally, there's also the component of monetization. as whether or not you're securing your content, frequently there are publishers who would want to monetize their content by inserting ads or advertisements into their video content. This is fairly common today, and there are also standards that are there today that are developed by the Interactive Advertising Bureau, or IAB, the VAST and the VPAID standards. And the VAST standard is the XML format for loading basic video ads. So think about a 30-second pre-roll, for instance, that you frequently see in many videos that you view. And the VPAID is more of an interactive, more for interactive ads like quizzes or other forms of interactivity, and it's more of an API or a Flash and HTML5 based standard that both the player as well as the advertisements need to implement. So, now that we've talked about the different components of having that you need to consider when you're thinking about the player that you want to use in your delivery chain, let's talk a little bit about the devices themselves and how the device ecosystem is really fragmented today. And I think you've seen and heard of a lot of these different devices out in the market today, and they are getting popular at different levels. But if you want to be able to deliver your video content to the widest possible viewer base, you need to think about how you will support delivery to all of these various devices, whether those are desktop or laptop devices, smartphones or tablets that are getting increasingly popular for consuming video content, as well as devices that are sitting in the living room, whether that's a television device or a game console. In addition to devices, you also need to think about security and delivering your content securely to the variety of different devices over the different protocols that are available today. Really the key takeaway from this slide, and I won't go through every single box here, but this is really just more informative for you. But the key takeaway is that a lot of these security features depend on the protocol or the format and vary by vendor. So if you think about DRM and Adobe Access, that really works well with Adobe's Flash Media Server RTMP streaming. If you think about PlayReady as the DRM solution, well, that works well with Microsoft Smooth Streaming. From an authentication perspective, if you look at the first column there, that's more of a commonality across the different protocols and formats, but your player should be able to support the token-based authentication. So there is an intersection there in terms of the various ways in which you need to deliver your content securely to your viewers, and how the player plays an important part in that. So with that, I'll turn things over to Jaron, and he can walk you through a little bit more about video streaming and HLS, and do a demo of doing HLS streaming with AWS and JW Player.
Thank you. So yeah, in terms of streaming, just very quickly an overview of why would you want to stream video and why not put an MP4 video somewhere and it works on every device. There's specific reasons for streaming to be better. There's the quality switching, which is a big part of standard like HLS. So you encode your video in 3 qualities, and the video player will automatically detect as you watch the stream what quality of the network is at, what quality the device can play, and then automatically switch up and down so that your stream is never interrupted and your viewer always gets the highest quality served to him. And yeah, in like a 3G to 4G to Wi-Fi environment, that gets super important as people very swiftly switch. For long-form content, streaming is also interesting, even if you're not into adaptive. because it allows you to control seeking. So think about a 1-hour video. You want to seek 45 minutes in, and then those 45 first minutes have to be loaded first until you can start playback at minute 45. And the flip side of that is when a user starts playing a 1-hour video and then bails out after 1 minute, you could have downloaded that hour of video. And that hour of video, that means a lot of bandwidth used but not actually utilized. So you pay for it, but you don't get the benefit of it as a publisher. And then thirdly, the various security schemes are pretty much tied to streaming formats these days. So if you think about DRM and encryption, you really have to go for a streaming format. Progressive video is much lower on security, and DRM is very typically part of a streaming protocol like Smooth or HLS or Adobe HDS. And then lastly, of course, live streaming is something that can only be done with streaming. There is no progressive file that can be played yet because the live event is in progress. And then in terms of HLS, with JW Player, we heavily focus on that format, and we heavily support that format because that is a format that in our view, allows publishers to play on every device that is popular. So you can play on all the desktops streaming. You can stream to iOS devices because it's built into iOS devices. You can stream to Android. There is web support in later versions of Android, but there is app support for all versions of Android. And then there is a couple of TV platforms like Roku, Apple TV, upcoming platforms like Chromecast that all support HLS. And if you look at the competitors of HLS, they are, for example, smooth streaming cannot be played on desktops or on all desktops because it requires a Silverlight component, and it cannot be played on iOS. And something like MPEG Dash is fairly new and has super limited support yet. So that's why we think that HLS is definitely the way to go and the format to use. Luckily, HLS is the format that is also widely supported by AWS. So what I want to do is just walk through a demo of how do you set up AWS services, both S3, the transcoder, and Cloudfront, to build HLS encodes and then play them in JW Player. So the first step is quickly go through S3 buckets. Then there's a couple of steps to set up in the transcoder. A pipeline, a job, create thumbnails. Then we go to Cloudfront. We set up a couple of distributions, and we make sure that through a cross-domain file, a player that lives on one domain can actually load the files from Cloudfront domains. And then lastly, we'll go to JW Player and then actually set up a video player and start streaming. So let me try to set up the screen sharing. Okay, so in terms of S3, you have to set up your S3 buckets, and that is fairly straightforward. You need an S3 bucket to set up your originals, and then you need 2 S3 buckets to upload your that the transcoder will push the files into, the video files into, and you need a bucket that the transcoder will push the thumbnail files into. Everything else on the S3 side is fine as is. And then in terms of the transcoder, there are 3 sections in the transcoder that you have to take care of. That's jobs, and then there's pipelines, then there's jobs, and then there is presets. So in terms of pipelines, you can set up a pipeline that reads your input bucket for new videos, and then you set up a pipeline that sets up, you set up in the same pipeline the output of your content to your video output bucket, and then the output of your thumbnails to your thumbnail output bucket. Oh, here we go. I actually have a live stream right now. So let me go quickly to the transcoder. So here I set up an example pipeline in Amazon Transcoder. And then you can see that I created an incoming video bucket for my original files. I created an encoded video bucket for the place to store the encoded videos into. And then I've created a thumbnail bucket for the place to store thumbnails into. So that is all set on the pipeline side. And once you set up a pipeline, you can create a job. And a job allows you to set up a video, or basically process one or more videos. So through the transcoder, you do one video at a time, but of course through the API, you can do tons of videos all automatically. So we'll use our HLS pipeline. I have one video in here called bunny.mp4. I'll use that as the input, and then as output key, I'm going to build a folder because the HLS streams are going to build a lot of different small files. So I want to organize that nicely, put it in a couple of different folders. And then Amazon has a couple of great presets you can immediately start using. So you can start out with the HLS without any configuration underwater. So I'm going to create a 2 megabit HLS stream, which is very high quality. So I'm going to call it 2 megabit. And I'm telling the Amazon transcoder that it actually needs to not build one big file out of it, but small segments of 10 seconds. And that's really the trick of HLS. So the small 10-second segments are being loaded one at a time, so the stream can be played over HTTP. And let me add another one as well. So we'll add a lower quality one, like an 8 megabit stream. We call it 1 Mbps. And then we want that one 10 seconds as well. You want the segments of all your outputs, you want them to be the same. So when the player switches quality, it goes super smoothly because those segments are aligned. And then let's add a third one. And then for the third one, we're going to go for a very low quality one. I'm going to go for a 400 here, which is, it will be a little choppy, but it will stream through 3G, which is important for mobile devices. So I'm going to call that one 400K, same 10 seconds, and then we're all set. One thing to add to just one of the outputs, you don't have to do that to all outputs, is create a couple of thumbnails. Basically, right now, the transcoder will extract by default, I believe it's like every 10 seconds or so, it will extract the thumbnail from the video, and you can use that as a poster image in the player later on. And then finally, now we have 3 components of our stream, and then we can create a playlist, and the playlist is actually the single entry point to the entire stream. It binds the 3 streams together. I call the playlist index, and then I'm going to add the 2 megabit stream, the 1 megabit stream, and then the 400K stream to it. So at that point, we have all our streams ready to go, and then you hit create new job, and then the Amazon transcoder will start running, build your MP4 video. So quickly going through the job, I created that video in here. So it's already live. It's this one. So by default, the bit rates are 2 megabit, 1 megabit, 400 kilobits, and then there's a couple of other preset bit rates in there. And by default, the thumbnails of AWS are fairly small. So one thing you may want to do is actually make the thumbnails a lot bigger. And that is something that you can, in addition to changing other parameters or adding, for example, a watermark, you can do by editing the presets in the transcoder. So I would encourage people to first utilize the presets to get the entire pipeline going. But once you're have the streams working, you can jump into the presets and really tinker everything to your needs. Then, when Elastic Transcoder is all set up, the last thing we have to do is create Cloudfront distributions. And those Cloudfront distributions will sit in front of our output S3 buckets. So we have one for the output S3 thumbnails, which I already created. And then I can create another one for the output videos. So you want the web output to be used because those are HTTP and HTTPS. And the origin domain name, I created a encoded videos one, so we're going to use that one. Everything else is fine for now. Create the distribution. Beware that it takes a little bit of time to create a distribution. So that is something that typically, sometimes it's done within a couple of minutes, and sometimes it takes up to half an hour. Amazon on the back end is setting up things. Now, with all the files set up, you can actually go to JW Player and sign up for an account and get the premium version of JW Player. That's the version where our HLS streaming is included into, and that one will immediately play your HLS streams. There's another edition, the Enterprise Edition, which also includes advertising, etc. There's a smaller edition that does not include HLS. So if you're interested in HLS, at least check out this one or go one further up. Inside the JW Player account, all you actually have to do is copy-paste the URLs of your HLS stream into the wizard, and then copy-paste the URL of your poster image into the wizard. And then JW Player will automatically create a preview for you. You can tinker with that preview, set skins, set presets, etc. And then when you're completely satisfied with the video player, you can click on Get the Embed Code. And that is actually providing you with the final embed code that you need to put in your site. So put this in your head, the top section. Put the bottom section. That's actually the embed code. This is the player library. So put the bottom section in the page at the location where you want the video to appear, and then you're all set. Just like with Amazon on the preset side, on the JW Player side, there's a lot of different options and configurations that you can change to add advertising, add social sharing, etc. But for the purposes of this demo, we'll just quickly get it going. And then in the end, you have a fully working copy of an HLS video that works on all your desktop browsers, that works on your iOS devices, and it works on your Android devices. So that's it in terms of the demonstration. So, the basic process is fairly straightforward. There's a lot of room for tinkering both on the Amazon Transcoder side and on the JW Player side, but just wanted to confine to the basic process. So there is early success. If you want to read through the steps of actually setting up that entire Amazon pipeline and setting up JW Player, I have here 2 blog posts that we've written that walk you through exactly those same steps, and you can read through them and follow them at in your own time. And then for JW Player, we actually have a 10% discount for the premium player. That one is AWS 10. So if you go to the pricing page, you buy the premium player, insert AWS 10, you get a 10% discount. That's it as far as the demo goes, and I'm going to now give it back to Nihar, and then we'll take questions from the audience.
All right, thanks, Jeroen. We will now answer some of the questions we had received during the course of this webinar, and we will also be following up on the other questions after the event by reaching out to you through email. And the first question here, it's for Jeroen. Can you explain a bit more about JW Player's Android support, specifically how the SDKs work and whether we can pre-roll ads using the SDK in Android?
So JW Player, there's 2 ways to play content onto Android. Android devices, some Android devices support it built-in, which means that it's fairly difficult to get a consistent experience, and that is something that you get with our web player. So our web player relies on the built-in capabilities of the devices. And then the second way is indeed through an SDK for which we have that we have available that allows you to play HLS into 2.3 devices, 4.0 devices, 4.1, 4.2, et cetera, et cetera. I would strongly encourage everybody who is interested in that to contact us, so we can walk them through the capabilities of those SDKs. It's really a deep programmer's tool, and not something you can set up with a couple of lines of HTML. It's very powerful. And it does support like a pre-roll ads, HLS streaming, but it definitely requires a little bit more explanation in terms of how exactly to set that up.
Thanks. The next question is for Nihar. Could you give an overview of what metrics about streaming quality and usage are best obtained from the CDN and which ones are best obtained from the player?
Sure, yeah. So, you should really think about the metrics that you want to collect about your viewers and their experience as a combination of what you can get from the player and also from the CDN from a server perspective. So if you think about from a CDN perspective, you want to look at the CDN metrics primarily for how the CDN is interacting with your origin server. So that gives you a view of your cache hit and miss ratios, which of your content is more cacheable. It can also give you a sense of which content is more popular from the perspective of, what are my top video files that are being viewed, time of day, the different browsers, and things like that. Where the player can really add value is when you think about the experience that your viewers are having in terms of buffering, or how many times are they having to reload or refresh their players, or if there is any stuttering or things like that. Also in terms of the throughput that's available to the players, what bit rates the player was playing. So these are all metrics that you can get from a player perspective. And to get the full end-to-end picture, the best thing that you want to do is combine both sets of log files or log data, and use something like Amazon's Elastic MapReduce, which is a Hadoop-based service where you can combine the 2 sets of data and create meaningful insights and end-to-end reporting for your viewers' experience.
Thanks, Nihar. The next question is for Jeroen. We have a viewer who is asking if you could explain a bit more about streaming only audio streams using HLS and playing it on JW Player, whether that's supported and what are some best practices to do there.
So audio only is indeed also supported, both by JW Player and as of very recently by the Amazon transcoder. Some best practices around it are make sure that that your audio is like basic AAC, baseline AAC, so it plays across all the devices. In terms of segment length, I would also use the same 10-second segment length that is also being used for video. Shorter segment length allows for better granularity in seeking, but it could cause the player to destabilize on 3G or 4G networks where there's a lot of latency and it's very difficult to quickly fetch the segments. And the last item that we see a lot also on the audio side is actually the ability from HLS to encrypt the fragments. That allows you to make sure that only your own player is playing that audio and not like other aggregation sites are stealing that audio and like monetizing your audio content. The encryption is supported also in JW Player. And another item that we see quite frequently is the ability to actually put video ads in front of audio or in between audio. Some stations use audio advertising also through these VAST and VPAID standards, and other stations actually use video advertising before their audio streams because there is a much larger inventory in video advertising than there is in audio advertising. So if you're into media, news, sports, that could actually be something for you to consider.
Next question is also for Jeroen. Can you explain a bit more about JW Player's HTML5 support? My understanding was that HTML5 video player is always provided by the browser.
Sure. So an HTML5 video player is, at this point, almost always provided by the browser. The only browser that has a significant market share, doesn't do HTML5 yet, is Internet Explorer 8, which probably hovers around 10% at this point. That a browser supports HTML5 does not necessarily mean it supports the video format that you want to stream. So there's a lot of progressive support in browsers. However, there's very little streaming support yet. Effectively, the Apple ecosystem, iOS, and Safari are supporting streaming, HLS specifically, and Firefox does not support streaming yet. Chrome is now beginning to support streaming through what is called the Streaming Media Extension. And Internet Explorer 11, also coming up probably within weeks, is also supporting that streaming through the media extensions. But those are all like new versions of the browser. So if you look at streaming, you'll look at a market share of it's a fairly small market share, but it's probably halfway there. So if you rely on the built-in capabilities of the devices and browsers and you want to do streaming, that would mean you miss half of the audience. And that is why, for streaming specifically, video player is very important. And then in addition to the playback, there are reasons around the customization that we talked about. So the ability to skin a video player, make sure that it looks exactly the same across all devices. There's functionality like HD switching built into JW Player and other video players that are not part of the standard HTML tags. And there's items like playlists, sharing functionality, popping up related videos at the end of your playback. Those are all things that are generally provided by video players, but are not provided by video tags. And then finally, something that is quite big and for JW Player is the ability to insert advertising. So pre-roll, mid-roll, post-roll advertising, or the VPAID interactive advertising. So those that want to monetize their video content have to rely on a video player.
Thanks. And one last question, and that's also for Jeroen. Can you explain how how subtitles are supported in the JW player, specifically for both the live streaming and the on-demand use case.
Yeah, sure. So for on-demand, there is the VTT format, which is a format that is part of the HTML5 specification, and it is a plain text format that allows you to load subtitles into the browsers that support it. So there's not all browsers supported yet. However, JW Player allows you to load those VTT files and play them on all browsers. And that is our best look in terms of on-demand content, both progressive and streaming. Using VTT is our preferred setup. There are other formats that are slightly older, SRT, which is big in the video where scenes, and you have DFXB, which is a system that is in the broadcast, or a format that's in the broadcast scene fairly big. Those two are still supported by JW Player, but for on-demand, I would strongly recommend using VTT format. And then for live streaming, you have the same issue as you had with the video file, that there is no file yet. But for that, HLS actually has support for captioning inside the stream. There's a number of transcoders that do it, and there's also the Wowza Media Server that actually can ingest streams with captions. JW Player then sees those captions and automatically pushes a CC button into the video player through which you can toggle those captions on and off. So for live streaming, a combination of Wowza Media Server, an encoder that allows you to ingest those captions into the Wowza Media Server, and JW Player would get you closed captioning.